Welcome to class PM. Today we are going to discuss mathematics 7th class state board. Here we are having the topic integers. Integers. Before going to know about the integers, we should know some basics. Then we will go for the integers topic. Basically everyone knows numbers, right? So who given the numbers? That is my first question. In every class for the number system, this is my first question to the children. Who given the numbers? Right. God given numbers. But man manipulated the numbers for his convenient way, for his daily life situations, for applications. Some other words we can say. We are going somewhere. We want to take something from the fruit market in the counting or weight or measurements, any process we are using such numbers. So we changed the type of all numbers in our daily life situations. So before going to know that integers, we should know about the natural numbers. So natural numbers we are denoting with capital N. Everyone knows. And set of natural numbers we are showing within the flower brackets. Natural numbers are nothing but counting numbers. So we should start with 1 onwards. We should not start with 0 anywhere. So counting numbers are called natural numbers. We learnt earlier classes about that. Clear. Coming to the W. W is nothing but whole numbers. Everyone knows. How can we say the whole numbers means? If we include 0 to the natural numbers, such numbers are called whole numbers. The set of whole numbers we are writing 0, 1, 2, so on, infinite. So these two topics we studied in the previous classes. Now we will discuss about the integers. So integers generally we are denoting with I or Z. Everyone knows why should we use the N and W for the natural numbers and whole numbers. In the natural numbers, N is the first letter. That's why we are using N to recognize easily. In whole numbers, W is the first letter. That's why we are using to recognize the whole numbers. And coming to the I, integers. In the integers, I is there. That's why we are denoting. Then why should we denote with I? Right? So some of the members know, maximum members does not know about the Z. Why should we use? Here Z is a German word. Meaning of the German word is to count. Actually German word is Jelhan. Jelhan, meaning of Jelhan is to count. That's why we are using integers with I or Z. Coming to the topic, we are denoting with I or Z for the integers. We are showing the integers with flower brackets and we are writing that in integers. We know the natural numbers, whole numbers. How can we define integers? Complete whole numbers including negative numbers are called integers. So how can we take? We are taking negative numbers from minus infinity to minus 1, 0, 1, 2, so on, plus infinite. How can we say the negative numbers? Right. So whenever we are taking number line, we used in the earlier classes, everyone knows how to represent, how to write the number line. So in the first class, we started with 0, 1, 2, so on up to infinite. After that, in other classes, we are taking 0 is the midpoint of the number line and 1, 2, so on we are taking. And here minus 1, minus 2, so on we are taking here minus infinity up to minus infinite. So here 0 is the neutral middlemost value in the integers. Right side of the 0 are called positive numbers and left side of the 0 are called negative numbers. So how can we define negative numbers? Means a reflection of positive numbers are called negative numbers, or the numbers which are having the minus sign before the numbers are called negative numbers. How can we define the positive numbers? Means the numbers before we are using plus or nothing, such numbers are called positive numbers. This is very clear for the positives and negative numbers. And coming to the our textbook, in the integers also we are applying basic operations. So basic operations are nothing but addition plus, subtraction minus, multiplication into, division divided by. We are using that basic operations. In between integers, how should we calculate? What is the rules we are following? We will discuss here. In the integers, we are applying the basic operation of addition. We are taking example different type of numbers. In the first example, I am taking 2 and 3. We need to add 2 plus 3 is equal to 5. Everyone knows these are the belongs to integers. So 5 is also a integer, belongs to integer. And second one I am taking one positive, one negative. 2 and minus 3. Both are belongs to integers. How should we add? Same. 2 plus of minus 3. I am adding here 2 positive numbers I am taking. Here one positive, one negative number I am taking. So 2 plus minus 3, whenever we are having in the calculations at a time, one after another basic operations, we should use the multiplication. Plus into minus, minus you will get. Now we are doing addition actually, but what we are doing? We are doing the subtraction. Why? Because after applying the multiplication, here we have subtraction. So minus 1, this also belongs to integers. Then coming to the third example, I am taking 2 negatives here, one positive, one negative, here 2 positives. How should we apply? Minus 2 plus of minus 3. Minus 2 plus into minus, minus 3. Then minus 3 minus 2 we are adding minus 5. It is also belongs to I. Here we applied addition. In one case directly we are adding for the 2 positives. Here one positive, one negative, we are doing here subtraction, but it is a addition. And here 2 negatives we are adding, 2 negatives, again we are adding negatives. So 2 positives we are adding, 2 negatives also we are adding. Only one case we are adding, means it is the subtraction, that is the one positive, one negative. This is the way we are solving the integers, either positives or negatives values. Coming to the subtraction, I am applying here subtraction. So I am giving example 1. So here 3, 5 belongs to integers. So 2 numbers are positives. So I am applying here 3 plus 5. It is the addition. But we are doing here subtraction. We need to use minus sign. 3 minus 5. Minus 2 we are having. I will give you clear information. First we are doing the calculations. And second one I am taking minus 3 and 5 belongs to integers. One negative, one positive number I am taking here. Here 2 positives I took. And coming to the subtraction, minus 3 minus of 5. So minus 3 minus 5 is equal to minus 8. It is also belongs to integers. Here we applied subtraction, means directly we are doing subtractions. Here we are applying subtraction, means here doing addition. Means previously when we applied in different manner, here also we are getting the different manners based on the values. Here we are applying subtraction, but we are doing addition. Keep in your mind. And third one, 2 negatives I am taking. Minus 3 minus 5 belongs to I. Then solution I am doing here minus 3 minus of minus 5, minus 3 minus into minus plus 5. Then we are having 2 belongs to integers. So this is the way we are applying the basic operations, one addition and the subtraction. Coming to the next one, multiplication. So two positives I am taking here the multiplication. So here I am applying 3 into 2, 6, it is also a integer, and second one I am doing here minus 3, 2 belongs to integers, 1 positive, 1 negative integers I am applying here. Solution, minus 3 into 2 is equal to minus 6 belongs to integer, and third one I am taking both the numbers negatives, and coming to here we are having, so minus 3 into minus 2, minus into minus plus 2 3s are 6 we are having. This is the way we are applying the multiplication. That is the one of the third basic operation. When we apply basic operations, we should keep in our mind how should we apply the basic operations. We are having rule, when we take one positive number into positive number, then we are having positive number. If we take negative number into negative number, then again we are having positive number. If we take one negative and one positive, then we will get negative value. If we take positive value into negative value, again we are having negative value. These are the 4 basic conditions. If we know, we should keep in our brain, we can do all calculations of integers. So means when we multiply two positive numbers, we will get positive number. If we multiply one positive, one negative, then we will get negative value. Again, when we apply multiplication in between two negative numbers, automatically we will get positive value. This is the rule of these 4 conditions. And coming to the number line representation of integers, when we are doing addition on number line, always we should go forward direction. I am giving one example, 2 plus 3, I am taking number line here, I want to take 0 here onwards, and left side values we can take minus 1, minus 2, so on, and coming to 1, 2, 3, 4 and 5. So in the addition on number line, we are going with 0, 0 to 2. So from rightward direction, right side direction we are going. So 0 to 2, we are adding 3 to 2, then the value should be become as 5. If we want to take 6 to 7, that is our wish. So we added here, from here to here 2, then we added 3. So 1, 2, 2 places between the values, and here 1, 2, 3 we added. The value is 5, we are rounding here. This is the way we are adding the addition on number line, forward direction. And if we are having, so second one, coming to one negative, one positive. Here already 2 positives applied on number line. And if we are taking one positive, one negative, how should we add? See, we are drawing number line here. So here we are taking 0, 1, 2, 3, 4, and here minus 1, minus 2, minus 3. Then we will go for 0 to minus 1, left side, and we are adding 3 to minus 2. Then our rule is we are taking this procedure, we are adding 3 to minus 2. So then from minus 2 onwards you should count 3 places. So here 1, 2, 3. So this is our answer. This is here we are taking 1. This is the way we are taking on number line 2 positives and 2 negatives also we are having. Here we are having 1 positive, 1 negative. And coming to the third one, 2 negatives. How should we add on number line? Always in integers, better to take 0 is the middle on the number line. And 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Here 0 to we are doing we are adding addition minus 2 plus minus 3. Then what we'll get? Without doing our regular process, it is easy to find out the answer by representing the on number line. And we are going 0 to minus 2. And we are adding minus 3 means we go with the 3 steps. Why? Because here we are having minus 2, minus 3 and minus 5. Previously I said 2 negative numbers we are adding means we are adding. 1 positive, 1 negative means we are doing subtraction. 2 positive means we are adding addition. 2 positives, addition. 1 positive, 1 negative. Automatically we will get subtraction. 2 negatives, automatically we will do addition. So this is over minus 2. Then we are going 3 more steps. So minus 2, 1, 2, 3. So this is our answer. In this manner we are showing the addition of integers on number line. Now coming to the subtraction. How should we apply subtraction on number line? I am taking here 2 and 3. We know 2 into 3, 6. Means here number of steps, it is showing number of steps. Number of steps we are jumping. And how many moves times we are saying this one. 2 times, each time we should jump 3 steps. That is the meaning of this 2 cross 3 or 2 into 3. Then we will get 6 is the answer. See, 0, 1, 2, 3, 4, 5, 6, 7 I am taking. So we will go with each and every time 3 steps we should go. So 0 to 1, 1 to 2, 2 to 3. This is the 1 step over. Then 3 to 4, 4 to 5, 5 to 6. This is our answer. Means we are jumping 1 time 0 to 3. And 3 to 6 is the second time. So 2 times we jumped. This is the 1 time, this is the second time. From 0 to 3 1 time and 3 to 6 is another time. Totally we jumped here in the multiplication 2 times, and each time we are moving 3 steps. This is the meaning of the multiplication showing on the number line. So after completion of addition, we will go for the subtraction, and then we will go for the multiplication. How should we represent on number line? So I am taking here for subtraction one problem 2 minus 3, and the second problem minus 2 minus 3, and the third problem 2 minus 3. 2 minus 3 means here I will tell you clearly. Here we are taking 2 positives, 2, 3, and second case we are taking 1 positive, 1 negative, and third case we should take 2 negatives. Positive, negative, 2 positives, 2 negatives. 3 cases we are doing here. So first solution, how should we subtract? 2 minus 3 is equal to minus 1 we are having answer. But this we should show on the number line. So I am taking here 0, minus 1, minus 2, 1, 2, 3, 4. So from 0 to 2 we are moving and subtracting 3. So 2 to 1, 1 to 0, 0 to minus 1. This is our answer. We subtracted. We shifted 2 steps right side. Then from that place we are moving left side on the number line where we are reaching. That is our accurate answer. And second one negative and 1 positive. Then surely we will get minus 5, minus 1, minus 2, minus 3, minus 4, minus 5 we are taking. So we will go 0 to minus 2. Again we will go backward direction here from minus 2 to minus 5. So this is our answer. And coming to the third one, so negative numbers, then minus 2 plus 3, then we are having 1. how should we show? Here see. So minus 1, 0, 1, 2, 3, 4 and 5 I am taking. And from minus 2 onwards we should move. So first we are moving from 0 to minus 2. 2 steps we jumped one time. And we are adding minus 3 means we are doing subtraction of negative number. So here one step, second step and the third step. Then we are having the value here. 1 is the answer. In this manner we are doing the subtraction, we will get the right answer. And coming to the multiplication. So 2 into 3 is there. The answer is, everyone knows, 6 multiplication. So what is that? How should we take? In the addition we are doing a rightward direction on the number line from 0. And subtraction we are going left side direction from the 0. This is the two rules we are applied in the addition and subtraction. Coming to the multiplication, how should we get? So here number of steps each and every time, how many steps we need to move, it will represents. And this one, this is the how many times we are moving. See, I am taking 0, 1, 2, 3, 4, 5, 6 and minus 1, minus 2. I want to move 2 times only to get the 6. How many steps we are having? 0 to 1, 1, 1 to 2, 2, 2 to 3, 3, 3 to 4, 4, 4 to 5, 5, 5 to 6, 6. 6 steps we are having. But number of steps only 3. Means each and every time you should move 2 times is taking. So 0 to 3 one time over and 3 to 6 second time over. So I said 2 times only 3 steps. This is the step. So this is also step, this is also step. So here one step, this is the second step, this is the third step. So first time, one time we are jumping 3 steps, second time we are jumping 3 steps. Total we jump 2 times, in each time 3 steps. The value is 6. This is the way we are showing the multiplication on number line. And last one more basic operation we are having on integers division. How should we divide? Same, we are taking positive integers, negative integers, positive and negative integers. How should we divide? See, I am giving examples 1, 2, 3 positive numbers. How I am dividing? See, 2 divided by 3, 2 by 3. This is not a integer. And coming to the next one, 15 divided by 3. So how we are doing? 15 by 3. 3 ones are 3 fives are. Then coming to the third one, minus 15 divided by 3. How we are doing? See, minus 15 by 3. 3 ones are 3 fives are. Then we are having negative value. Here positive value, here negative value we are having. So in this manner we are dividing the integers. If we are having positive numbers or negative numbers, or both positives or both negatives. Next one topic, some important properties we are applying on the integers. Properties. So first one, closure property or law. Both are same property, law both are same. Closure law. So here we are taking a comma b, any two integers, then a plus b also a integer. If a, b are any integers, we are applying a into b, it is also a integer. This is the for addition, this is for multiplication, and we are taking a minus b belongs to a subtraction. If we are applying closure property means, if we are taking two integers, if we add or if we multiply or if we divide, if we subtract, again we are getting the integer, then the closure property satisfies. This is the meaning of the closure law. I am taking one example here. 3 and 7 belongs to integers. First one I am applying for addition. So 3 plus 7 is equal to 10 belongs to I. Satisfies closure property. And subtraction I am applying here. 3 minus 7 minus 4, this also belongs to integer over, and multiplication 3 into 7 21 belongs to integer, and division 3 divided by 7 means 3 by 7, it is not a integer. So closure property satisfies addition, subtraction, multiplication, but does not division. This is the one property. And coming to the next property, second one, commutative property or law. Here also we are taking only two integers, then implies what we are doing here, a plus b is equal to b plus a, or a into b is equal to b into a, or a minus b is equal to b minus a, and a divided by b is equal to b divided by a. This is for addition, this is for multiplication, this is for subtraction, this is for division. Means here also we are taking two integers, but if we reversing in the both the way, if we are adding a to b or b to a, both the way the answer should be same, then commutative property satisfies. I am giving one example. 3 and 4 belongs to integers. First one, for addition I am taking 3 plus 4 is equal to 4 plus 3, 7 is equal to 7, so it is right, belongs to integers, both the values are same, means for addition commutative property satisfies. And coming to the second one, subtraction, 3 minus 4 is equal to 4 minus 3, here minus 1 is equal to 1, so both are not equal, so it is wrong, it is right. Commutative satisfies addition but not satisfies subtraction. Coming to the third one, multiplication, 3 into 4, 4 into 3, 12 is equal to 12, belongs to integers, it will satisfies. And coming to the division, fourth one, division we are applying, 3 divided by 4 is equal to 4 divided by 3, so 3 by 4 is equal to 4 by 3, so both are not equal, LHS is not equal to RHS, so it is also not satisfies. Means closure property satisfies in a different manner. So in addition, subtraction, multiplication, it is satisfies closure property, division not satisfies. And coming to the commutative law, it is satisfying the addition and the multiplication but not satisfying the subtraction and the division. Coming to the third property, associative law. Here we should take three integers, that implies if we apply the properties or basic operations, we are adding first two integers, after that we are adding the third integer, the value should be equal. When we are applying, we are adding second and third integer, afterwards we are adding the first one, the value should be same. This is the associative law for the addition. And if we are applying subtraction, a minus b minus c is equal to a minus of b minus c, and if we apply a into b into c is equal to a into b into c, and if we are taking a divided by b into divided by c is equal to a divided by b divided by c. So these are the cases we need to apply here for the associative law. I am taking one example, 2, 3, 4 belong to integers. I am applying addition. So 2 plus 3 plus 4 is equal to 2 plus of 3 plus 4. 2 plus 3 is 5 plus 4 is equal to 2 plus 4 plus 3 7, and 9 is equal to 9. So LHS is equal to RHS. So associative law satisfies under addition. Coming to the subtraction, 2 minus 3 minus 4, 2 minus of 3 minus 4, and 2 minus 3 1 minus 4, 2 minus 1, and minus 1 minus 4 minus 5, and here we are having 1 plus minus into minus plus, then we are having 3, so both are not equal, 3 is not equal to minus 5, it is not satisfying. coming to the multiplication. 2 into 3 into 4 is equal to 2 into 3 into 4. 2 3s are 6 into 4, 2 into 12. Here 24 is equal to 24 means associative satisfies. And coming to the division. 2 divided by 3 divided by 4 is equal to 2 divided by 3 divided by 4. And 2 by 3 divided by 4 is equal to 2 divided by 3 by 4. Then we are having 2 by 3 into 1 by 4 is equal to 2 into 4 by 3. Then we are having 2 by 12 is equal to 8 by 3. Both are not equal. So division not satisfies. So means here we are applying association property, associative property in the integer. It is satisfies only the multiplication case and the addition case, and division subtraction not satisfying associative law in the integers. Coming to the next one. Now the last one property is distributive law or property. Here we are having A, B, C are the three integers. Then we are having two situations here. One is the multiplication over addition, and second one is the multiplication over subtraction. How? A into B plus C, A into B minus C. So here these are the two conditions we are having. We are extending, distributing. So AB plus AC and AB minus AC. These are the two conditions satisfies the distributive property satisfies in the integers. So I am giving example 2, 3, 4 integers, and I am taking here the first one, multiplication over addition. How we are taking? 2 into 3 plus 4. Here nothing is there means multiplication, and 2 into 3 plus 2 into 4. Then we are having here 2 into 7 is equal to 6 plus 8, 14 is equal to 14. So it is satisfies. Distributive law, multiplication over addition satisfying. And coming to the second one, multiplication over subtraction. 2 into 3 minus 4 is equal to 2 into 3 minus 2 into 4. So 2 into minus 1 is equal to 6 minus 8. Then we are having minus 2 is equal to here minus 2. So LH is equal to RHS. In integers, both the sides we are having same values, same sign, we can cancel also. So minus 2 minus 2 will be cancelled. Then 1 is equal to 1. Any manner it is right. 1 is equal to 1, same, equal. So in the integers, distributive law satisfies for the multiplication over addition, for the multiplication over subtraction. Coming to the identities. Identity law. Here we are having two laws. One is additive identity and multiplicative identity. So for the first one, additive identity means one is the additive identity. When we apply integers for the addition or subtraction, we are having the value is 1, then it is called additive identity. If we are having additive identity laws 2, we are having one is the additive identity, multiplicative identity. Additive identity means it is the 0, and multiplicative identity means 1. How should we say 0 is the additive identity? If we are taking two integers, we are adding to get 0. So here we need to take minus 2. Then only 2 minus 2 is equal to 0. So here it is the additive identity. And coming to the second one, if we multiply 2 with a number, then we need to get 1. So it is possible by taking 1 by 2. So 2 ones are 2 ones are will be cancelled, then we are having 1. So such numbers are called here 2 minus 2 are inverse numbers in addition, and here 2 1 by 2 are called inverse numbers in multiplication. So 2 minus 2 are the inverse, additive inverse to each other to get the additive identity element, and 2 1 by 2 are multiplicative inverse to each other to get the multiplicative identity. This is the identity loss, inverse loss and identity loss we are having. In the integers, when we add two integers, we will get three answers. How? I will show. If we are taking two positives, then we are having positive value. If we are taking two negatives, we will get negative answer. And if we take one positive, one negative, then we will get 0. These are the three conditions I am going to say. I am taking one value 5, 3. Both are the two positive numbers. I am applying addition. 5 plus 3, 8. It is a positive. Clear. In addition, if we apply two positive numbers, we have positive. Then the second one I am taking minus 5 and minus 3 I am taking. And here minus 5 plus of minus 3 is equal to minus 5 minus 3 minus 8. What I said? Negative over. And the third one, if we are taking one positive and negative to get the 0. How? Right, I am taking 5 and minus 5. I am applying addition. 5 plus of minus 5 is equal to 5 minus 5 is equal to 0. What I said? The three conditions over. In the addition, if we are adding two numbers, we will get three answers. One is the positive, the second one is the negative, and the third one is 0. That is based on the situation, based on the question, we can say. So this is the complete chapter of integers in your class. You have any doubts, you can raise your questions by asking, and we are ready to give the clarifications. Thank you for watching this. Thank you.